Hello, astronomy. This is Dr. Smith. A few of you have emailed me about some problems that you've been having trying to solve the parallax problems and the magnitude problems. So I've decided to upload this little quick tutorial to try to help you out. So the first problem that you're going to see is distance to nearby stars. And this one is pretty straightforward, but we need to talk about this one because you need to know how to solve the first problem to get to the second problem. Now, let's make sure we understand what this means. So distance equals 1 over parallax angle. Okay? And the parallax angle is actually here where you see the theta. You can see it better on a previous slide. So this is the parallax angle, and then this would be the distance. So if you imagine the distance of the star to Earth, so imagine, for example, a person standing at position 1, position 2. Some two objects, for example, maybe even satellites. And then what you're trying to measure is how far is that star from Earth. And you can do so by using the equation distance equals 1 over parallax angle, measured in arc seconds. And this little theta represents arc seconds. So if it's 0.77, then it will be distance equals 1 divided by 0.77. And again, you can see the theta here. Now, one thing I also want to note is that your distance can be in kilometers, parsecs, or it can also be in light years. If it's in light years, the constant changes. So here you would find distance equals 3.26 divided by the parallax angle. The same procedure that you would follow. The only key difference here is that instead of using 1, you would use 3.26, and distance would be in light years and not be in parsecs. Now the next type of problem is a little bit more complicated, and that's looking at distance and magnitude relationships. This is actually based on the inverse square law that's found in your textbook. And it starts on page 296 in your text. And it goes all the way to page 299, and you can see the distance and magnitude relationship, Discovery 10-2. Let's make sure you understand the difference between apparent magnitude and absolute. So for apparent magnitude, it was originally started looking at the luminosity, how bright a star is, by using 0, +1, +2, +3, etc. So the closer you were to 1, the stronger you were, in other words, the brighter you were, more luminous. Well, later they found stars that were even brighter than the +1. So they had to start going on the opposite side of the integers, -1, -2, -3, etc. So the more negative the number, the more luminous, the more bright that particular star is. That also means the closer the star should be then. So if you notice, unlike the distance equals 1 over the parallax angle, this is a direct relationship between the magnitudes. So for example, we just talked about the apparent magnitude, and notice where the D is. The D is on top of the division bar. Also notice the D is on top, and it's also related to the absolute magnitude. Now let's talk a little bit more about the absolute magnitude. So that's how bright a star would be given a certain distance. If you remember, D equals 1 over parallax angle. And if you remember also that D equals 3.26 light years, in other words, 3.26, that's the constant, over the parallax angle. This is ideally the same thing, except you shift 1 over when you're talking about absolute magnitude. So here we have 10 as the constant, and likewise, because it's not 1 anymore, we have to do a shift to the right to be 32.6 light years. In other words, that's the constant that we use for the distance light years. Now for this equation, and you won't have to memorize any of those particular equations, they will be given in the particular answer or the particular question that you're asked. M equals the capital M, or absolute magnitude, equals apparent magnitude minus 5 times the log of the entire value, which is D divided by 10. Okay. Now that can get a little bit tricky of how to put that into the calculator, so I'm going to show you that in a little bit. Excuse me. But I will also say that, notice, is D. So usually you're not going to be given D. You're going to have to figure that out from the first type of problem, which D equals 1 over the parallax angle. And once you figure that part out, then you plug it in. So if we take a look at the steps, and this is the same type of problem here I'm going to use from Discovery 10-2, what you will find is step 1, calculate D, the distance, using the equation D equals 1 divided by the parallax angle. So the second step is to substitute everything into the formula. So your D, you have to be given either the absolute magnitude or the apparent magnitude. So you have to have 2 of the 3 variables to solve this equation. Now let's do a quick demo. Okay. Okay, so we're going to solve the same problem that's on page 299 in your textbook Discovery 10-2, which is on the top of that page. Now notice what it says. Consider Proxima Centauri, the nearest star to Earth. Now by measuring the parallax angle, we know this star is at a distance from Earth of 1.3 parseconds. So that's the distance. That's what we need. Its apparent magnitude is m equals plus 11.1. Okay, so just a quick go back. So we know this number is a plus 11.1, and this number is 1.3. Now we have everything else, and we can just simply solve. So if we go back to the log calculator, notice how I put everything in. 11.1, okay, minus 5, then click log. Your calculator should immediately have the parentheses coming up. Now if it doesn't, you can just simply click the parentheses. The next thing you want to do is put in 1.3. Now some calculators have like the little slant that looks just like it does in the textbook, which means the division board. But if not, just simply hit divide. That's what it means. And 10. And then we're going to hit the equal sign. And what you should get is 15.5. Now notice, it's not a negative number, so you can automatically assume it's a positive number. So that's a plus 15.5. Okay. Now hopefully this helped. If you need additional practice problems, please let me know, and I will definitely email, or I can put it up on the web study timeline. Okay, hopefully this helps. Have a great day. Bye-bye.